My name's Reagan Cole, and this is What's in Water. So sometimes when drinking a glass of water, it can taste different than drinking a glass of bottled water because there's different molecules and compounds and minerals in that. But what does one do when water is contaminated? How can you tell it apart from a glass of normal water? So using IR and NMR spectrums, we can tell the difference between the two. And why is this important? So the objective of this lab was to identify the three unknown compounds isolated from drinking water. So I will be talking about how I concluded what each unknown was and how I went through that process. So before testing began, there were different tables that we needed to fill out so that we could compare our findings with the NMR spectrum and our IR spectrum back to those tables. So the thermoscientific spectrophotometer was used for the IR spectrum, and the EFT60 was used for the NMR spectrum. So the IR spectrum detects absorption of the photons, which shows wavelength. That's what it produces in the spectrum. And NMR does the same thing. It takes the absorption of the photons, but it shows the hydrogen nucleus, which is the protons. And that was given to us by the Department of Chemistry in our lab manual. So this first table was given to us in the chemistry manual, and you can see there are three different colors of functional groups that were present in my IR absorption scan. So the first is the CH single bond, then the OH bond, and then the CCl bond. Okay, so this next table we had to fill out on our own, and it shows the functional groups that are present in each of the 15 different molecules. So on the left-hand side, you can see 4 different molecules that are circled. Those were molecules that I found based off of the functional groups in my IR spectrum. So this was my IR spectrum, sample 25141, and you can see the 3 different colors are there with the OH bond, the CH single bond, and then the CCl bond. All 3 are labeled here. And based off of those 2 tables from the values, I concluded that the possible compounds in this sample was methanol, ethanol, T-butanol, or T-propanol. Now, another table we had to fill out was the NMR spectroscopy of the 15 different molecules. So all 15 molecules are here, and as labeled, T-butanol was found in my NMR sample spectrum for sample 25141. So this is my NMR spectrum as circled. Those are the area ratios, and that ratio is 9:1 with the 2 different peaks. So going back to the previous table, there was only one molecule with this combination, and that was T-butanol. So based off of both of these tables and my findings, the IR spectrum and the NMR spectrum, with the OH and the CH, I concluded that this was T-butanol. And how I did this was for the IR spectrum with its table, the OH bonds and the CH single bonds were present, but I decided to leave out the CCl bond simply because there was no combination in which all 3 were present. Only OH and CH were present, not all 3. So that's why I decided that the CCl was unimportant to my findings. With the NMR spectrum, only one molecule was present, which was the T-butanol. So cross-comparing my results from the IR spectrum and the NMR spectrum, T-butanol was present in both. So that's how I concluded that the unknown in my sample was T-butanol. Okay, so going back, the objective of this lab was to identify the unknown compound in the sample of drinking water. So using the different tables, I was able to cross-compare my findings with the IR spectrum of sample 25141 back to the samples 25141's NMR spectrum. And cross-comparing those, like I said previously, the result was T-butanol. Again, this was all from the chem manual. The objective was. Okay, so now we're going to take those and what that means for the humans and the environment. So T-butanol in humans has not been tested, but it has been tested on lab rats. So in lab rats, there was failure with the kidney, and it just overall was negative. It had a negative impact. And but since it was never tested on humans, there's still evidence that an increased amount of T-butanol can cause increased risk of cancer and deterioration of the kidneys. But on the other side, T-butanol can be beneficial or have no impact in the environment. So it's very biodegradable and it does not accumulate in soil or water, it just simply goes through. So it doesn't really have a significant impact just because it doesn't cause harm to anything. So overall, T-butanol can be negative to humans, but it doesn't really have an increased effect on the environment.